Hello everyone. In this video I'm going to go over how to make a laser security system or a trip sensor for lights or whatever you would like in Home Assistant. I'm going to accomplish this with LDRs, with D1 minis, and of course a laser. Now a use case I had for this was I had a hallway that my dog would always trip the motion sensor on. So I made essentially a tripwire that would bounce off a little tiny 1x1 mirror on the hallway and back. It's at chest level. That way only humans could triple it on and off. But this same concept that I go over in this demo can be used for anything you'd want. Security systems, say James Bond movie, or whatever you can think of. Either way, I hope you enjoy. Alright, so what we need to accomplish this is a LDR, and I like to use these larger ones here for stuff like this. And we need a 10K ohm resistor, and a Wemos board, and of course a laser, and then some mirrors. Now the concept of this is pretty simple. The laser comes out, bounces off a mirror, which then bounces off another mirror, which bounces off another mirror. Eventually we'll hit this LDR. The way I do it is I put these pins in here. I have tons of these little boards that I've already made. This helps make sure they're straight. You just pick which side that you want these things to be on, and I always face it out, just in case you ever want to use the USB connector. But you want a nice solid cone. Alright, so now what we're going to do is we need the 10K ohm resistor, of course the LDR, but my LDR is not going to sit on here like in the diagram. It's going to be on this. So we'll make wires to go from there to there. But the first thing we're going to do is we need to wire this up to where the D1 mini board is actually connected to power, because I don't like using the USB. I like to do direct connections. Now we're going to connect the 10K ohm resistor. So now what we're going to do is we're going to connect the one side of the 10K resistor to the analog pin on the Wemos board, and that's the very last pin on this PCB right here. Once that's complete, what we're going to do now is we're going to make a connection from the other side of the resistor to the 3.3 volt pin on the D1 mini. And then what we're going to do is we're going to put these screw down wire connectors in, and we're going to go ahead and solder that in as well. That way we can then connect to the external LDR that's not directly on the board itself. And what I'm doing here is I'm putting a jumper on to allow for me to have that pin in a nice neat place. Alright, now it's not clean looking, but the whole point of me doing it this way was just to emphasize where things go. So essentially we're pulling a 10K resistor to ground right here, in between that and the LDR. The LDR, since it's on this, is going to connect to here and here, back to the 3.3 volts in analog. So we'll go ahead and do the solder some wires to the actual LDR now. So once we get these soldered on, real nice and neat here, and it's very good to make sure it's clean. That way we can use these the wire tube, heat shrink tubing, to make it have a really clean look and to keep the ends from touching each other. But just overall to make it look clean. The way that we're doing this is that these wires are just going to connect into here like that. Now obviously whenever you do this, or if you actually want to use it in production or whatever, you want to make it look cleaner, but that's the way it's going to look for our demonstration. So now let's switch and get on the computer. Alright, so the first thing we're going to do, now that we have all of our wiring done, is in the link in the description you'll see this link to my GitHub. You're going to download the Windows Tasmatizer, or the Linux version if that's what you have, but go ahead and open it, and you'll see that right now there's nothing in there because I don't have anything plugged in. But let me plug it in. Hit refresh, and now I got one there. So what we're going to do is go ahead and do that. We're going to select this, hit release, and we're going to do just the Tasmota bin. Tasmatize. And it took mine about 40 seconds, but I guess it just depends. Awesome. So once that's complete, what I always do is I'll unplug the device and then plug it right back in. So now what's going to happen is you should see it in your Wi-Fi networks. It should pop up. I'll go ahead and connect. So now you're going to type in all your Wi-Fi information. Once you're connected, you go to your router to figure out what IP address it is, and then you're going to give it a dedicated one. And since I'm using pfSense, right here, so once I apply that, now I'm going to unplug my device. I'm going to plug it back in. And then once I do that, I should be able to connect to it. There it is. So now for the fun part. We are going to go back to my GitHub. And these are just the default settings I always use. I always click on them no matter what because they're very generic. And then now we're going to do some basic configurations. Now I have my thing open up on the other screen so that I can copy and paste, but pretty much all this stuff is going to be on the GitHub page. Now I'm just going to set my NTP servers, which you don't have to, I just always do. And now you'll see a few things, like for example, you'll have the host name and stuff. So now we'll go to configuration again, we'll go to module, we're actually going to switch it to generic. Then you can also do some other things, like you can rename your device. I'm going to name this one Laser Demo. Another one I like to do is I like to change the host name of it. And in this case, I'm just going to name the host name Laser Demo as well. Now let's switch back to the workbench. Now we're going to go ahead and connect our board. This little sloppy PCB I made. I'll go ahead and make these connections as well. So once we make all of our connections, we're going to switch back to the computer and do some more setup. So now what we're going to do is we're going to go to configuration, module. We're going to switch that AO pin to ADC light. Now you'll see there's a luminescence reading. So now if you watch it, I'll break the connection. The luminescence reading goes down to 4 because there's still light in my room. Now you can break it off at any of the mirrors and it will do the same thing. So it's the same concept for if you want a security system anywhere else. So the next step we're going to do is we can either leave this as is and see it in Home Assistant, or we can make this as a sensor. And earlier I told you to set 19 to 1. You need to set it to 0 for it to be an automatic connection in Home Assistant. So we're going to configure MQTT. this would be your Home Assistant instance. Now, what do we want to call this device? I'm going to call it Laser Demo. Now, the username is whatever you have set up in Home Assistant. Mine is Morgan's Mods MQTT. Then you type in your password and you hit save. Now you'll notice there's this little MQTT slot up here. So now let's go check it out on Home Assistant. It should pop up in the Tasmota integration. And there we have it. So now it's here. So now you can do things like either base automations based simply on just the luminescence, or you can create a template sensor to make an on or off switch, kind of like how I did with the washer and dryer. If it's anything above a certain amount of watts, it turns it on, etc. So I hope you found this useful, and I hope you can take this to the next level for your security system. Thanks for watching.
Like and subscribe.
Like and subscribe.